troubleshooting. Why I do this is because I want to literally talk about troubleshooting, but you guys are already going to see, you've been through it before. So you're going to have a lot of questions that are going to be answered because you already did it. So now, I don't have a link. That's the first thing. Remember what happened? Do my frequency matches. That's the first thing I want to check. Did they match in all your cases?
Yeah.
Not whatsoever, right? Okay. Off mode. Transmitter was off. But besides that, the ODU was actually powered off as well. Polarization. In this case, it's really not important because it's on a bench test, but if we were to grab the ODUs and just start twisting them around, cross-pull, you will see a 20 dB difference. You will have a good MNC, but your RSSI will be 20 dBs apart.
And will you say that 20 will be equal on both sides?
No. You want to have 40 and 60 on one side. That's the giveaway. It's 20 dB difference from one to the other.
So 20 dB out is like a phase shift?
Yes.
Yeah.
That's why it's shifted. Now, ACM settings for the pluses radios, they have the feature ACM enable or disable. In the past, you have to have either both on or both off. In the new radios for iron and links, they're always on by default. Data pad settings. Again, for the TDM radios, you have Ethernet, E1 plus T1, and the new ones is only Ethernet based, so you don't really need to worry about that. IDUs, ODUs are swapped. Does that happen to you? Mm-hmm. Somebody went out to the site and took the wrong ODU. God. Realistically, what could happen is somebody could take the wrong IDU. The IDU, I'm really not concerned because you can always reconfigure that. But the ODU, you guys have to swap it physically, right? Imagine doing that on a tower. Have to climb up, bring that again, all that thing. Loopback mode. We didn't talk about loopback. Loopback is to test the actual IDU and OMU if it's working correctly. Do loopback auto, and it will give you a lock. If it comes up with a lock and a good MNC value, the IDU itself is fine. Fuses. All of them powered on, no problem. If I have no lights, you have to go and check the fuse as well. Core MNC. What causes poor MNC? Too high transfer power. So right now, if I crank up the power, it's gonna go straight down my MNC, okay? Target RSSI. If it doesn't really match, ATPC is gonna try to kick out the power every time. IF cable issues. That's the first thing to check. Jeremy, you're on the right track. One of my IF cables is not the best, but it will work. But when you spot something like that, that's the first thing to check, right? Come in, check out the end connector. Even if it has moisture on it, probably replace it. Interference. Now, interference shows up this way. RSSIs will be good, but your MNC will not be able to go any higher at all. That's serious interference. There's a practical test for interference. Turn the far side off or reboot it and do a link test on the local side. When the far side is powered down, the value should be -90. If it's not -90, somebody is transmitting on your frequency or close to it. Okay?
That's a good tip right there.
And pretty simple. Okay? Just reboot the far side and let a link test run. 99. Low RSSI. Alignment. Okay? Don't call me and say, I cannot, what is my RSSI problem? I'm gonna go back and align it. What did I tell you? Number one installation frustration, go back and align it. Polarization. If it's cross-polarized, that 20 dB difference is gonna be really noticeable. Waveguide. Using waveguide, really expensive. However, you have all the extras that come with it. Again, target RSSI. Commands I want you to know. Status monitoring will give you the MNC value, RSSI, BVRs, FVRs, log status, and TR. Status PLLs. Status PLL, the ODU itself has a series of PLLs. The PLL for transmit and receive, OMU, and IF PLL. In a normal link, when you do status PLL, everything should be 1. Everything should be locked when you're transmitting. If you have one side transmitting but not receiving, one that receives status PLL is going to be 0. At that point, no way around it, RMA. Not even worth it, just send it back. Status port or TDM. As we said before, we want to check if there's some traffic hitting the Ethernet port. For the products Apex Plus, status port for the new product, status show. Okay. Troubleshooting tools, link test. Favorite command, really simple, really useful for interference and live status. Loop back. If the loopback comes back positive, it's 1 and good MSC value, the problem is not the actual IDE or the ONE. Diagnostics. Diagnostics command, it's only a file checksum really. It doesn't go into details of voltage or anything like that. It's in my calibration file there, am I missing something in the file server? But it's really not a critical troubleshooting tool. It's just everything is in the radio, basically file-wise. Syslock and lock level. Syslock, what happens at the end of a radio, right? Always, it clears the lock. So you want to have a syslock server pointing to that. Debug, I like debug a lot. Debug you can do with ping, you can SSH, you can telnet, and do a route. You can see what route's taken back to the gateway. Uptime. If you think the radio unlocked, but it rebooted, do the uptime command. It will give you how long it's been powered up after the reboot. Again, troubleshooting here is no link lock, no link. So you're doing the link test, we check the RFTX frequency, modulations, the duplex spacing, channel bandwidth. No link at all, alignment, link alignment. Again, ODU polarization, are they mounted correct polarized, or are they both high side or low side transmitters? NEC is too high or bit errors are showing when running link test. Okay, this is again IF cable problem. That's the only thing can impact the NEC.
Can you be clear on MSE high versus low? Like, so MSE, a high MSE,
Will
a
be
bad MSE is like
15.
neg 10,
yes.
and a
15,
good
10.
MSE is like neg 40.
Yes, remember, you want to have negative 35.20 and above, you hold that 1024 com link. So anything below 20 really is going to drive you to QPSK.
You want a higher absolute value,
Yes.
which means lower errors.
Yeah. My RSSI is too low. Has to be alignment or the power on each side. So we check the transfer power.
We are going to send you guys the slides.
Yeah, this slide you're gonna get. Yeah. Now I'm going through them because a lot of things that we talked about, it's all described here, but we already went through it and you guys saw physically what are the effects of having things in wrong places. RF link is good, but no packets, but packet loss occurring. When you have packet loss, check your Ethernet cable first from your switch to your actual data port. That's the first thing to check, and then the latency on the link.
We use a Fluke.
Okay.
We use their link runner. I think it is now. I don't know. We've got like a $1,400 Fluke box that just tells us whether it'll do a gig, 10 meg, or 100, and it will also test the shielding.
Oh, good.
So you just, it's. I can't remember.
Internet tester.
Yeah. Well, it basically it's more than a continuity test.
I think it's the link runner because it has a wire map and has the it passes the voice over IP or Gigi test.
Yes.
Yeah.
I think
it's
that's
the
what
link
it is.
runner.
Yeah, but it's a nice, and then you turn it on as one button test. And we gave one of those to every one of our wireless techs, so that anytime they're testing a cable, we don't have to know if the cable's good.
That's good. Radio management over the link. Remember, if you're using IBM, you will be able to manage the link across the wireless interface. If you use OBM, you have to go across the wireless link, go down to your switch, and then go back to the management interface. Reset button functions. Hold for more than 2 seconds but less than 6, the unit will do the following. The IP address will be reset to factory default. The CLI management password will be reset to default. The web interface will be back to default. SNMP strings will be back to default. CLI prompt will be back to default. If you hold it for more than 6 seconds, The unit will reset the system configuration to factory default, meaning the RF settings, but the items in number 1 will not be affected. Alright guys, shoot away.
Real quick to go over
Yeah.
radios A and B. Which one's the high and which one's the low?
High is the B, A is the low.
So when I do a model and it tells me my ODU is A, how do I know that it should be the A? And
On your PCN, there's going to be a location per site. So the 8 radio, you're going to see low site, is going to be on, let's say, Woodson. And on black is going to be my B site. Okay, so your PCN states where it should go.
so there's nowhere I can check in the radios.
You know, the radios tells you which is connected to the IDP base.
It'll be on your configuration report. too.
Oh, yeah.
You get that with the radios. On
Yeah.
configuring.
Yeah, we do all configuration for you guys.
What's the lifespan of the Giga Orion series, and how long do you guys plan to support it?
We'll support all our products until the end.
Until the end.
So, yeah, until they,
Until we stop.
yeah.
Okay.
No, support is still going to be
No,
available
it's
for all
it's
our
going to be in
products.
production for a long time. I don't know
Yeah.
the exact amount of time. I can just tell you the most recent example is Giga Plus. Right? We talked a lot about Giga Plus.
And
Giga
still-
Plus we started shipping in 2010, and we're still shipping it. Obviously, we're moving people to the new product. If you really want Giga Plus, it is available, and it will be available, generally available for any customer who has built network on that product platform for a number of years. I don't know exactly how long, but you know, we'll keep going. As far as support, repairs, maintenance, that's ongoing. We're still supporting Generation 1 radios.
Oh, wow. Okay.
You know, so you know, I would say there's not a hard set time,
But it's
I gotta
something.
go
but it's a long time. It's a long term.
James, John, thanks, appreciate it.
Sure.
Kevin,
Okay.
it was a pleasure.
Thanks.
Say hi to Ryan for me.
Yeah, we will.
Oh, don't forget your certification over there.
Safe travels.
Voltmeter.
Take care.
We'll do it right now if you want.
Thank you.
Does anybody else have questions?
Yeah, I'm certified.
We're going to finish right now, so we can just do this stuff.
The only reason I ask is because when we go out and build infrastructure to support stuff, I mean, we're like 10 to 15 year minimum. When we roll out with stuff and you know, build our power distribution plants and things like that. So I was just curious, is this something that we're going to be able to rely on for the next 10, 15 years?
Yes,
as a product.
And I'll further that. We're on to our 3rd generation now, where replacements need to replace
Right.
or upgrade are using the exact same antenna interface.
Okay.
So, for example,
We're making them backwards compatible.
yeah,
and
these guys are going in now, and they bought the Apex was different, but we came up with an adapter. So they put up an antenna that's 7, 8 years ago,
Right.
and it fit a certain radio, and we still
So you're
fit a new
thoughtfully-
radio.
Thoughtfully engineering
Yeah.
things and forward thinking. That's great.
Yeah,
Okay.
so, you know, 10 years from now, let's face it, I mean,
Right.
the radios are gonna be way better than they are today.
Oh, yeah.
And it's gonna be cheap. It's gonna be cheaper for you to just pop in a replacement.
Oh, I know what that is.
Yeah.
That's the diagram they drew for me.
Well, the way back, yeah.
Do you want to put it in a fridge at home?
Yeah.
But
What I
Triangle
like-
as a company is known
what I
for
like about this is
long-term
not
support.
having to drag around a ton